Last video we saw how the bubble sort algorithm works. We understood its algorithm, we understood the example, and this is what we formulated in the last video. Now I'm going to show you a step-by-step conversion of this algorithm into Java equivalent code to implement the bubble sort algorithm. For this I'm going to now the NetBeans, and here I'm going to create a package I'm going to call bubble sort as the name of the package. Now here inside bubble sort I'm going to create a Java class which I'm calling it as bubble sort. Okay. Now here what I'm going to do is, let me get rid of all these comments to make the code look as simple as possible. I'm going to create a main method here. Okay. Now the first step, as in any sorting algorithm, is to get the random array. Okay, now this can be done either by initializing or reading from the keyboard, or you can actually use the Java's random class to generate random numbers and store it in a array of integers. Okay, so for that I'm going to create an integer array. Okay, new int, let's say the size is 10. Okay, and I'm going to go through a loop. Before that, it's important you need to create an object of random class. Okay, equal to random. This is from the util package. There are two constructors. I'm using the no arg constructor here. Now here what I'm going to do is, instead of reading from the keyboard, I'm going to do something like this. Obj dot next int. Now this is an overloaded method. I'm going to use here the one which takes one argument, which means that the random numbers will be ranging from 0 to whatever the bound you mention. If you say here 100, the random number generated will be from 0 to 99. Okay, so this way this loop will generate the random numbers. Now we can actually verify this by printing the random numbers here. Okay, so you can say random numbers are something like this. Okay, and write a for loop here, I equal to 0 to 10, and it's better you always, instead of a hard coded value, it's always better you replace it with a appropriate variable. Now you can display here, okay, with some space, plus a of I. Now this completes the step 1, which is to get the random array. Now let me run the program and show you the output. It shows random number. Okay, so you can keep running it several times. Each time you get a different set of random numbers. What you have to note here is the random numbers are not exceeding 100 and above, because the range that we have set here. Okay, so this completes step 1. Now step 2 is the process of bubble sort. Okay, so here you can go through this, which we actually did in the last video. Okay, so let me replicate this in the Java code. Okay, so for that I need to declare this variable also. So I'm going to do declaration of boolean variable is swap. Okay, so this will be equal to, I think we can put this inside the loop. Okay, so we need to have a for loop which runs from for I equal to 1 up to a dot length I plus plus, and then we do this comparison. Okay, so I'm going to do this one, a of I minus 1, if that is greater than a of I need to do the swapping here. Swapping is very easy to perform. You know, this is a very familiar code for swapping. Temp equal to a of I minus 1. A of I minus 1 will be replaced by the value of a of I, and then in a of I we put the code of the content of the variable temp. Now this is a very familiar 3-piece code for swapping any two variables. Okay, so we are actually swapping first number with the second number. Okay, once we do the swapping, what we do here is we update the boolean variable, which is swap, to true. So here I'm going to make swap equal to true. Now, since this is not declared, let's declare it here. If you remember, eswapped variable is always made false before the beginning of the pass. Okay, so this is the beginning of the execution of the pass in bubble sort algorithm. So this is corresponds to one complete pass of the algorithm. So before that, this variable needs to be set to false. Okay, now this repetition of passing is repeated several times. Okay, so you can say here this is repeated do uh, while the value of is swapped is equal to true. If it is true, you need to repeat it. Okay, the moment it remains false, the algorithm will stop it. Okay, so this is because that the loop has been declared, the variable has been declared inside the loop. So let me move it outside the loop. Okay, so you can actually declare it here and make it false before the beginning of the pass here. Okay, so this gets rid of the, just did the formatting. Okay, now the code is ready. Okay, so bubble sort is ready. Now let me do step 3. Step 3 is to output the sorted array. It's very simple. I'm going to write a for loop here. Before the for loop, you can just say the sorted array is something like this. Now here a dot length. Okay, I'm just replacing it with an appropriate variable. Here you can just print the updated array which is now sorted. Okay, so from the algorithm, step 1, step 2, step 3 has been converted into Java code. This is step 1, step 2, which is same exact replica of what we wrote in the algorithm, and this is the step 3. Now you can run the algorithm, run the program. You can see here the array is now sorted. You can just try running it on a multiple set of random numbers, different runs. Every time we get a different random array, and the sorted array is as shown in the bottom line. Okay, you can see here this is now sorted. Okay, you have multiple numbers which is also correctly sorted here. Okay, now I'm going to show you in this code few things, like instead of this great, if you remember in the first video I told you that with the once we understand the algorithm, with simple change we can actually get the output in different order. For example, with this understanding we are actually getting the output in the ascending order. With small modification we can get it into descending order. The algorithm will perform with very minor change to the algorithm. So instead of this greater than, I'm going to put less than. I'm going to show you the output. You can see here the output is now sorted into descending order. Okay, so always it is enough if you understand one simple algorithm for either ascending order or descending order, and once you understand that version, by making a very simple change you can get the other order of sorting as well. Okay, now I'm going to introduce few more variables here which will actually print how many comparisons are done, how many swapping are done, something like that. So for that, number of swap is the variable which is basically set to 0. Okay, similarly number of comparison is 0. Now swapping is happening here. So what you can do is here after the swapping you can uh, increment this by 1, and comparison is happening here. Okay, so you can say here number of comparison plus plus. Now finally you can put those numbers here. You can say the number of swap. Okay, you can print it here plus and this one, and number of comparisons can be also printed in a similar fashion, and this is the variable. Now if you run the program, you can see here the number of swap is 17, number of comparison is 45. Okay, It depends on what type of input array that you feed in. Okay, in the next video I'm going to show you some more improvements for this algorithm so that you can minimize on some comparisons. Okay, also we will see what is the best case and worst case for this algorithm of bubble sort.